Good evening, everyone. I'm running a little bit late, and now my audio wasn't working either. Hi, Batuhan. Good to see you again. So what I was saying while you couldn't hear me was that tonight the plan is to look at this feature. It's called sys.unraisablehook, which is a new feature that Victor Stinner implemented for 3.8. And the idea is that there's a new function called sys.unraisablehook, which is called in certain situations. It's called when there is an exception that you would like to show to the user, but for some reason you can't because you're in a kind of strange situation. And that means you can't raise it, but you, right now there's, like in older versions of Python, there was a, there's simply some stuff printed to standard error, but there's no way to do anything with the exception. And this hook now adds a way to do something with the exception. The most classical example of that is an exception that is raised by a destructor, like a del of a user-defined class. So if you have a class, looks like this, and yeah, you can see that I still write a lot of Python 2 because I will make classes inherit from object. Anyway, let's say you have a badly behaving destructor like that. So if you make an instance of this object and you make another one, then the previous one is destructed because we're in CPython, and reference counting detects immediately that this instance is no longer needed. And then we run the destructor, but the destructor actually raises an error, and we're not really at a good place where we can actually let this exception go anywhere, right? We could be in the middle of whatever. It's some completely unrelated code that just happened to trigger the destruction of this object, and so it's not really a good idea to show this exception that we get here to whatever random unsuspecting code that doesn't really expect there to be an exception. So what Python does instead is that it will just print the exception to standard error, and then says I'm ignoring this exception. I cannot do anything with it. It was raised here. Here's the traceback, but it will not really. That you cannot catch it. Like let's try if we say we make a new object. By the way, the reason why making a new object destructs the last is the underscore variable. So we get this traceback and we get the exception ignore, but we didn't enter the except block because the exception is really not raised. It's just printed and then thrown away. Right, so that has always been the case. Python has always behaved like that. And the problem is that this behavior is a little bit bad in some contexts. In particular, if you're deploying some kind of web service and you would really like to know if this happens, because it's usually not a good sign, right? I mean, usually you should really write your dels in such a way that they don't raise. So in some way, if you ever get into such a situation, you have a bug. And so people that deploy web applications wanted a way to be able to catch this problem, right? They wanted a way to say, I would really like to be able to notify it of that situation, and then I can log it in some other way. I can tell, I can tell some logger, or I have some kind of crash service or whatever, and that's what sys.unraisablehook is for. So the new feature is that you can now say, let's define a function. I don't really know yet completely what kind of args it takes, but let's just append them to the list. And that now if we make another few such instances, then I made the hook, but I didn't set it anywhere, right? So I want to set it somewhere. I want to say sys.unraisablehook equal hook, and from now on we shouldn't get these prints, and instead we should get a calls to the hook, right? So we don't see the prints anymore, but L is growing. Now we can also see what what the arguments of a hook are. The hook gets, let's see, the hook gets one argument, and it's some kind of collection of things. It has the exception type, it has the exception value, it has a traceback, it has an error message, and it has an object. It's like some kind of context, right? So the hook takes one arg, and it looks like this. This is the argument, and it has various fields. Hi Julian, hi Ken Jaidup. Nice for you to join us. Right. So let's see. So that's the goal. That's what we want to do. And before we implement the actual feature, I need to remind myself how it works currently in PyPy, because I cheated a little bit and looked earlier, but it's really not my area. So let's start grepping. So we probably should look for this kind of string. Now let's grep for that. Right. And what we find is that there is there are 3 test files that have this kind of string. Test PyRs, sysmodule, and apptest user object, and they check that we get the message that we want, probably by capturing standard error somehow, right? And I suspect the apptest user object. Let's actually look into that one. This one. Where are we? Exception ignored, right? And it indeed does that. What it does is it captures standard error by using string IO, and then down here it sets it back, and then it checks that it has a del that raises a value error, and it needs a garbage collection call to make sure that the object is collected, because in PyPy we don't get this immediate collection of CPython because we don't use reference counting. And then down here we have a check that we indeed get the correct kind of message, right? So that's the test that checks the feature, and then the other hit we got when grepping is probably the implementation of the feature, and it's interpreter error, which sounds like a reasonable file name for that kind of feature. Oops, interpreter error, right? So let's look for ignored, right? And there's a function that has a promising sounding name, write unraisable. And now we can grep for where this write unraisable method is called. I'm also going to tell you the class that this method is on. Right. So let's see. Okay. We can get unraisable exceptions in the context of a generator or coroutine.close, or in an async generator finalizer. That makes sense. We can get it in threading.shutdown. That's also understandable. There's some kind of hook. CPyX. So from C code, it can happen that if we're in a callback from C code, then it means we cannot raise an exception through the calling C code. So that's probably what this is about. And yeah, a couple of places. A lot of them are obscure, but a lot of them we also understand. I'm kind of expecting there to be one for del methods, but I don't see those yet. Maybe we need to look a little bit more closely in a bit. Anyway, so that makes sense. I mean, those are sensible callers for this write unraisable function. Okay, I told you I'm going to tell you what the class is that this is called on, and to do that, it makes sense to understand a little bit how exceptions work in CPython and in PyPy. In what CPython does is it has this global exception flag that it will check after every function call on the C level that could raise something, and then propagate the exception up manually. And that's very annoying. So in PyPy we decided we don't want that, and instead our Python supports exceptions, right? And the way that we represent exceptions that happen, that really correspond to exceptions on the upper level, on the level of the Python program, is that we wrap them into instances of this class. It's an operation error, and it's an RPython level exception that signals an exception that that happens on the upper level, the application level. And it stores a couple of things. It stores a wrap type, which is the Python level type of the exception, and it stores a value, which is a Python level value of the exception, and it optionally has a traceback, right? And so if we catch this kind of thing, it means we have an exception that was raised by Python code, and then in some situations we want to not keep raising it. Instead, we call this write unraisable method, and then stuff gets printed to standard error. Right? Let's actually look at one of the callers. It was in generator, I think. Right. That's the closing of a generator, and if the close method calls an exception, so we wrap it into an extra except block. If reading the close method gets an exception, then we capture the operation error, and we cannot really do anything with the exception. So what we will do is we will say that this is an unraisable exception. So we call the write unraisable method, and then we ignore E. And there's this comment. Whoever wrote that doesn't approve with the way that CPython does it, but we still follow the spec. Okay, so we're getting a little bit more of an understanding of how things sort of hang together. We have these operation errors that correspond to Python level errors, and if we're in a situation where we need to throw one of them away, we call the write unraisable method on them. Right, so what now needs to happen is now we want to implement the hook. And the hook works in the way that instead of the old behavior that we had before, so the old behavior does all kinds of stuff, and it formats the string that should be printed, and then it has some somewhat strange code here that I'm going to explain later that prints the traceback, and then in the end it ignores all further errors, right? And then we're done. And the new behavior is that instead of doing this stuff, we call sys.unraisablehook. And sys.unraisablehook by default, basically on starting a new Python, contains the behavior that right now is in this method. So what we need to do is we need to move parts of the code in this method into the new sys.unraisablehook, and the new code needs to get the sys.unraisablehook function and call it, and then by default the old behavior will still happen, but you can also then override it and get the new behavior. Right. Okay, let's see. How do we start? I'm going to start by there's a lot of moving parts, so we need to start a little bit slowly. Let's maybe start by I want to add a new test file, unraisable, that contains all the stuff that we want to do, and it needs to import sys, and let's maybe start a very simple test. And I think the very first thing that I want to do is I want to implement something that I saw when I looked at the diff earlier. So if you look at the files changed, there is a test something file, right? Test sys. And it seems they have a test method called write unraisable exception that takes an exception and an object. And I think it's purely for testing, right? It's purely to be able to say, now I would really like to have this exception and kind of throw it away, but sort of writing it as an unraisable exception. And we don't have this helper function that you need to be able to write tests in that way, so I want to add it. And that's the first thing I'll do. In order to be able to do the same thing here, basically try raise value error, and then we catch it, accept exception as E, and then what does it do with it? It says it uses the task C API module, but I'm going to put it into PyPy module, write unraisable E, and it takes an object. What kind of object does it give? It's yet another. Doesn't matter. I'm going to pass none, right? And then in order to observe this, I want to set the standard error to string IO, I suspect, and then I should I'm going to factor some of that out into a reusable helper at some point, but let's start that way. Finally, sys.standard error equal load standard error, right? And then after the write unraisable, we should be able to say we should be able to say output equal string IO dot get value, and in there we want to see something like assert exception ignored in output, right? Is it like this? No, it's exception ignored in, right? And then we also want to say there should be the string value error in output, right? So this is all we're very slowly getting closer to the actual problem. This is just preparation work. We want to be able to test that, and to be able to test that, we need to sort of artificially be able to produce these situations where we want to write unraisable exceptions with this new helper function. We haven't actually implemented anything about the new feature, but I mean, given that we implement a new feature, it's always a good idea to think about how do we test this properly. So we go here. This is the __ PyPy module. It contains all kinds of magic things. And what we're going to add is write unraisable. Right, and it goes to the beautifully named file insert magic, write unraisable. This new magic. There we go. And we go at the end and we say def write unraisable, and we say, okay, it takes a space, everything takes a space, and then we say it takes an exception and an object, right? And I actually, yeah, let's do this. And then we can say, no, I actually want a small variant here. I want to add the where string that CPython doesn't seem to have, which is just basically any string test. So, and then we also say assert test place in output. All right. Okay, so what does it do? This new function, what it does is it says, okay, we need to make an operation error, and it takes the type of this exception object and this exception object, and calls write unraisable on it, and write unraisable takes a space and a where, which is a string which we have, and an object, which is the object, and the rest is kind of optional, right? And now we need to say that where should be text. Julian is asking whether the test that we see here, whether that's running against PyPy yet. It's running and failing. It's running. It's failing for the reason that we don't really have this function here, right? But yes, I mean the goal. I mean, once we're done with everything, we hope that all these tests pass, of course. But right now, I mean, we can look, right? We can go to the PyPy build bot and say, okay, give me the last 3.8 run, and in here, okay, the last 3.8 run doesn't seem to have run the libpython tests. Okay, so I can't show you, but basically, currently it will just completely fail because of everything, right? There is no sys.unraisablehook, and there is no testcapi.writeUnraisable exception. So right now it will run, but it's just completely failing. It's decorated with CPython only. That's debatable, right? We should probably remove this in our patched version of the standard lib, because it's a useful test for us. Right. Okay. Now we can run the test, and the test should work, right? Because what we're testing right now is the default behavior that existed already. So let me actually start the test. Because I should have started the test while I answered Julian's question. And yes, I encourage you to ask questions so that I can fill the time. That I wait for the test results to appear more productively. Right, so yeah, so a bit more generally about Julian's question. So all the tests in the CPython test suite are basically classified into CPython only tests, which are the implementation specific things, and sort of general language behavior tests. I'm not really completely sure why Victor added a CPython only decorator to this new class. I mean, I definitely would argue that unraisable, the new unraisable hook is a language feature. It's not really an implementation detail. So in some sense, maybe we should submit a pull request saying that please, I mean, from our point of view, it's really a general feature, so we should remove it. Right, and of course there's a typo. Great, standard error. Right. Oh yeah, that's correct. The usage is testc API. I'm not actually sure. I have the vague memory that we have a testc API. Yes, we have a testc API which is written in pure Python, as opposed to in CPython, where it's written in C. So here we have all kinds of things that you need for testc API, and we could even implement the write unraisable now by calling the new __ PyPy write unraisable, right? So in the end we should do that. But I'm not going to do that tonight. Right, yeah, I mean, Julian says that there should be a more official test helper API in CPython. I suspect that testc API is that. I mean, it would be an interesting question for Truffle Python, whether they have a testc API or how they do that. Right. Okay, what's happening to the test? It's still doing things slowly. Anyway, I should print the output because as we discovered last week, the yeah, great. Okay, wait again. Right, anything else obvious I'm missing here? We will see. Right. Okay, so what's the plan now? The next steps, we can think about the next steps. The next steps are we should we kind of carefully need to split apart this code into stuff that always needs to run and into stuff that needs to be done by the default hook that is installed when you start the interpreter. And the other thing we need to think about is we need to think about how we are making these kind of objects. So there's this unraisablehook args class. Maybe we can actually look at how CPython does that. It's defined in Python arrows. Oops. Right. Right, it's a struct sequence kind of thing. That makes sense. So if you've never seen that, it's a struct sequence is basically I think originally they were all tuples, but then it became a little bit too unreadable to always fish the right position out of that tuple. So now it's a new kind of type, a struct sequence type that has named fields that you can also access via their positions. And so we need to define one of them. And in PyPy they're a little bit strange, I think. Okay, something else is going wrong. Yeah, struct sequence type is like a built-in name tuple, exactly. It says Matti, and that's exactly it. And in PyPy, I'm going to remind myself how they work in a second, once I figure out why this is going wrong. It's just space.type. Right. So space.wtype is basically type, like the thing that the type object that is named type, and then there's a space.type, which is a way to get the type out of an object. And I used the wrong one. And now I need to wait 70 seconds again. Right. Okay, struct sequence objects. I wanted to grab for that, and I think there is one in sys, and so right. Given that we need to add new stuff to sys, maybe the sys module is a good place to also store this new kind of type. And let's look at one of the existing struct sequence types here. For example, yeah, the float info. Excellent. Right. So that's in system. Right. Matti tells me where they are, but I'm just going to copy paste this kind of code. So they're actually defined in pure Python code. They're not defined in RPython. We embed a little bit of pure Python code into our RPython code, and it will be run on top of the interpreter when we start. And we define a class here, and it has a meta class called struct sequence type, and it contains some fields. And they have numbers and doc strings, I think. And then they will be turned into something that looks like a struct sequence. So let's copy that, and we will put it into module sys. I suppose VM is a good place. So let's define the new struct sequence type somewhere at the top. Oops. I do that. Like this. Right. Let's check what it's called. It's called unraisable hook args. And it has some fields. What do the fields look like? The fields are here. Batuhan is asking why they're not implemented at like other basic types like tuple. I suspect they could be nowadays, maybe even should be. I don't know. That's the right. So let's number them. 0, 1, 2, 3, and 4. Excellent. And then yes. Right. So now we have a struct sequence type. Yeah, I don't think there's a good reason why they're not implemented as all the other types. It's kind of fun to do them in this way, right? Like this. It's really just Python code. It's completely normal Python code. I mean, I guess you could ask a similar question. Why are named tuples implemented in pure Python, right? I'm not sure they still are, but they used to be. And yeah, it's kind of easy to write them as regular Python code, and that's why it was done that way. I don't think there is a deep reason for it. Right. Okay, so now we have the type. What does our test do? Still running. That's good, maybe. Is it still doing work, or is it hanging somehow? No, it's still doing work. Good. Let's hope it comes up with a result eventually. Okay, so now we can make these things. We can make instances of this, and what we now need to do in write unraisable is we need to make an instance of the hook, and then we need to call the sys.unraisable function in the sys module, right? So there needs to be what's the test doing? Okay, the test is passing. I have no clue why it's taking 300 seconds, but it's passing. That's great, because it means that we know that. I mean, we're not testing the new behavior yet, but at least we can make sure that now we are going to refactor things, and now at least we can make sure that after the refactoring, stuff still works in the way that it did before the changes. Right. And right. So modules sys module def. Here we will define a new thing somewhere at the bottom that says unraisable hook and it's going to be in vm.unraisablehook, and I think there's also another thing called right. There's another thing called __unraisablehook, which is basically a backup attribute for the same object in order to make sure that you can get it back. You can get the old behavior back by overriding this with the stored value of the default hook. So they both look like this. Right. Cool. That looks plausible. And now we need to think about what the default unraisable hook looks like. So what does it get? It gets the hook args, right? And what does it do with them? I don't know. Yeah. What's happening here is not completely obvious to me. I'm going to put an ellipsis here or an XXX. It needs to do the old behavior using the attribute stored in the hook args. Let's work on the other side a little bit. I mean, I tend to kind of, if I do these two things and I don't quite know how to continue one of them, then I sometimes go back to the other side and try to progress there. Okay, so what should happen here? There's all kinds of stuff. I'm going to ignore it, but the goal is that we want to make a hook args implementation here, right? Somehow we want to construct an instance of this class here, this class, right? So, and let's actually look at it, how that works, right? So we have the float info here. Let's look at how the float info, oops, sorry, is actually called. Why is the editor not cooperating? Hello. Right. And it's called by making a list out of all the arguments, like all the fields, and then we call the wget method on the strange app object that we wrapped our app level code into, and then we say call function. So we're just going to steal that code, and we want to have something like this here, right? And then the hook is right. The hook takes the info, and then now we need to make all the information. So what is the information? What information do we need to put into the hook args? Let's see. So there's the type, the value, the traceback, the message, and the object, right? So where do we get the type from? The type is easy because the type is a field on self. It has a type. So we can say self.wtype. How do we get the value? Let's actually peek at what the previous code did. So it got the type by saying self.wtype, okay, like we did, and then it calls a method getWvalue, right? That makes sense. Put that here, and then we say self.getWtraceback, that's a space, and so the next thing we need is a message, and I suspect the message is related to this where thing somehow, right? Space.newText where, maybe not quite, maybe that still needs a little bit of, we need to add something to that, I'm not quite sure. Right, so that was it. No, and the object. And the object is we get that passed. It's just it can be none, so we should be careful. If wObject is none, we should use a wrapped none. There are two kinds of nuns. There's a none on the RPython level, which will be translated to a null pointer in C, and then there's a none on the Python level, which is an RPython level instance of the class w_none object. Okay, that looks good. So we pass these fields into the info, and then we have the hook args. Right. Now we should get the hook. How do we get the hook? We get the hook by saying, okay, space.sys, that's the sys module, get dict value unraisable hook, right? I'm not quite sure, maybe get dict value needs a space. I think it does. Right, and then the next thing we can do is we can call it, and that's space dot call function whook and function, and the argument is the whook args, right? And then we're done, kind of. There are just a few problems. We need to be very careful that we cannot raise an exception here, right? The code here really wraps everything into a try except and ignores all exceptions. And we need to do that too. We need to think a little bit about what here can raise exceptions. So, and I think this can, and calling the hook, of course, can also raise exceptions. And if the hook raises exceptions, I think what CPython does is it will fall back to calling the underlying hook, so that the exceptions from the hook, from the overridden hook, are reported using the default hook. But we should maybe read the CPython code a little bit to figure out how that works. So we make the hook args, we read the dict, the hook out of the dict. If the hook is none, what do we do then? We need to think about that. Not in the except block. What do we do here? I don't know yet. If the hook is none or not callable, then we, I think, let me see. Example hook equal none, not explicitly. Okay, but anyway, I think if it's, I saw that if it's none, the default behavior is used. So the default hook is used. Well, the tests again. Tests. Original razor, wrong type. Custom unraisable hook fail. Right, so if the custom one fails, then we still get it. Right, then we get the error exception ignored in hook function. Right. Okay, that makes sense. Right, so we should, what it's saying is that we should wrap this into an except operation error as well. Right, XXX here, and I think, yeah, let's think about the error cases a little bit before we continue. Here we don't manage to construct the hook args, and that means we cannot call the hook because we don't have the arguments, right? Here it means the hook is none, which can happen, or not, or somebody deleted it, and here it means that calling the hook produced an exception. And I think in all three cases, we should basically not really fall through, but we should do the old stuff. We should do whatever code is down here. Right. Okay, so that's the basic shape of things. And now we need to hook up the default behavior again. And I'm not quite, yeah. I think I want to move the code that's down here into a new method default. It has the same signature, maybe, maybe not. No, it doesn't. It probably doesn't have the same signature. Right. Maybe it's not a method. I think it's not a method because it really gets a type and a value and not. It doesn't really need an operation error. So I'll make it a static method, and it gets value where a traceback, where is basically like the error message, and an object which is maybe optional, and with traceback whatever that is, and an extra line. I think extra line is something that only PyPy does. We can grab in a few moments how when that ever is used. Right, and here, I mean, we should call it in a few places here. Here we should call it with saying self.write_unraisable default space w type w value. Yeah. We didn't call it w value here. We should. Right, WTB. Right, there's a comma missing. Yes, it's a bit of a slog, not as bad as last week. Right, so the plan is to here, when the exception failed, we should report that by saying something. Let's look at CPython. I think that's the next sensible thing to do. Where do we construct this thing? It's the init, right? Make unraisable hook args. So who calls that? Here. Right. PyError write unraisable message, and this is equivalent to this method, right? And so what does it do? It fetches the exceptions and the value in the traceback. It if there's no exception, then we have a problem. It tries to get a frame and a traceback from the frame. It calls normalize exception. Interesting. We also need to do that. Then it has some cases for when the traceback is none. I think that happens automatically for us. And then it does some formatting. This is all before the hook is called. So we should all do that too. For example, it does this little bit of formatting. If the message string is not none, then we prefix it with exception ignored format error. And then we call the make unraisable hook args. If that fails, we go to error. Then we get something from sys. If that's not there, we go to the default hook. Then we have the audit call, which we don't implement yet, so we'll ignore that. If the hook is none, we go to the default hook. Then we call the hook. If that raises an error, we fall through to the default hook. Right. Right. Okay. I'm learning two things. I'm learning that I need to normalize the exception, which the code down here did, I think. Yes. Here. Let's do that. That's basically, we should have copied this code in the first place. Right. So we normalize the exception. We get the type, we get the value, we get the traceback. If the object is none, we use w_none. Now we can delete these two. Right. And we don't need to do it down here. I'm commenting them out in order to see how the out code still worked. And then there's some formatting going on here, right? So what I don't quite know yet is who calls wrapper. Is wrapper called by the default implementation or by the thing that calls the hook? I'm not really seeing what happens with object. Is it just passed or is it formatted in some way? No, it's just passed. So the default hook calls wrapper. Julian says he found a PyPy bug. Please tell me what the bug is. Maybe we can fix it at the same time. Right. Okay, so this formatting here should move up to no. All this code should go up. Right, so here we want to, before we create the hook args, we want to do something like, we don't have the object wrapper yet. But a little bit of formatting still is happening. Right, so a bit of string formatting. Yeah, there's some strange difference about the traceback. Was there a comment that I should copy? Yes. Maybe I can, wait, let's read the comment. Since 3.5 unraisable exceptions are always printed with the traceback. Okay, I will kill this because we are in, no, it's actually still useful because what it explains is that the with traceback actually doesn't mean whether we want a traceback or not. It just means we get a slightly different message. Right. Okay. So we did some string formatting, and we want to pass that into the hook. Okay. Cool. So what does the default hook do? What the default hook does is it if there is an object, it tries to call wrapper on the object. If that fails for some reason, we ignore the error and just say use object wrapper failed as the wrapper. And then we print the first line. And the first line needs to contain the object wrapper somehow. Let's do this. First line, object wrapper, and a new line. Right. And then we pass that in here, and there's some application level code that calls standard error write. If there's an extra line, it will print that, and then it will import the traceback module. Why is it done that way? Import the traceback module and then print the exception. Cool. As we can see here, the default hook could as well be written in purely app level code. I mean, calling wrapper and ignoring exception could just as well be done on app level. So maybe we will do that later. Okay, but not yet. So all the XXXs are right unraisable default, type value trace back first line maybe object with trace back extra line. Do we need with traceback now? I think not. No, it's not used down here. Makes sense. It's just used for the strange different error message. Cool. And the extra line is printed after the first line, right? Okay, that looks good. If there's no hook, let's actually look at what CPython does there. What happens if, right. So what CPython does is if we fail to be able to make the arguments, then it replaces the error string, and we should do that too. So we will steal that error string. So we somehow failed to make an instance of unraisable hook args. So we will call this with the new first line. If the hook is none, what happens then? If it's none, we don't change the default hook, and we don't change the error message, we just go to default hook. So we can do that. The default hook, we get like this. And I think we can write that a little bit less strangely with these 3 calls to write an unraisable default, but I'll do that in a moment. So what happens if the call fails? Then we use this as the error string. So here it failed, and oops. We use this as the error string. Right. Okay, so let's restructure the code. Hi, Luke. Good to see you. Right, let's restructure the code a little bit. So let's see. We can say else. Oops. Right. And then how do we get rid of this one? We say space is if not right. What's the error message is if the there's no change in error message if the unraisable hook is not set. Right. Okay. So let's see. Let me read this code again to make sure that it makes any kind of sense. We get the hook class. We construct the hook args. If then we read the unraisable hook. If constructing the hook args yeah, that's a bit strange. That should be its own. Let's be a little bit lazy. If reading that fails, we say exception ignored in buildings. Okay. If we have a hook and an argument, if the hook is not none, we call it, and if the call works, we're done. If the call raises, we switch to the error message exception ignored sys.unraisablehook, and then we, if we're still in the function, we call the default behavior and we're done. Right, okay, that was a little bit complicated. Right, and the default behavior is basically what was there before. Are we still using self for anything? No, we're not. Great, so it is a valid static method. Okay, great. So the main thing missing before we can actually run a test is we actually need to define the new thing here, the new sys.unraisablehook, right? And what that does is it takes all the hook args, like all the fields of the hook args, and it will unpack the arguments again and then call this static method. Right? So it needs these arguments. And we need to read the arguments from the hook args. So what are the arguments called? Exact type, x value, x traceback, error message, and object. Right. Value, x value, error message, error, what was it? Error message. Right, and we want to turn that into an RPython string like this, and then we want to have the object, and that's space.getUtter hook args object, and then we have the extra line, and we need to think about what to do about the extra line. But then now we have all the things, and now we can say operation error dot write unraisable default type value error message object extra line. So what do we do about the extra line? We pass it through the hook args as well. We add a new PyPy specific field to the hook args, and we will add the extra line there. Right. So extra line, and the trick is, if you don't want it to be readable as a tuple field, you leave a gap in the numbers. It's a little bit of a weird it's a little bit of a weird interface. Okay, and now we need to pass the extra line here. Like this. Okay. Maybe that works. We wrote a lot of code without running any tests, so that's I'm going to discover 37 typos, but let me actually start the test. That's S. Okay, so what is happening in the chat? Right, Julian found a bug. And he So in Python, if you set a except hook to something not callable, then you will get an error in the except hook, and that will be chained. If you do the same thing in Python, in PyPy, what happens? you get error calling sys except hook is not callable, original exception was, and then something crashes. Ha! Because show trace hook calls except hook again. No. The bug is this part, right? I mean, the upper part looks good, but then actually, what I can show you what crashes. It's absolutely related. What crashes is immediately where we are. Yes, misspelling static method is certainly a great typo. Right. What crashes is the fact that the traceback module will also try to use sys.acceptHook, but sys.acceptHook is broken, and that means we get that from show traceback. Run code. Something escapes somewhere. It's a good thing to fix. It's probably quite close to where we are currently. I really suspect that it's this line here that I'm not sure. Or it's our REPL that should work slightly differently. One of these. But yes, it's a fun bug where we see even more internal exceptions. I mean, you see lots of things that you shouldn't even see. You see PyPy interact, and then lots of details from the traceback internals, and yeah. Right. Okay, what's happening with our tests? It's still running. So while it's still running, we can look at the PyPy interact thing. Where is it? Not there. That's calling. That's the code module that's calling. I don't know. I mean, our shell is very different than CPython's shell. Our shell is in pure Python, and CPython's shell is strange. Right. Okay. So more typos. Here we misnamed. Right. Right, that looks good, better. I suspect there will be 12 further typos. Okay, but yeah, it feels like we're making progress. So far we're not testing yet that it's actually possible to override the unraisable hook, but we at least managed to introduce the unraisable hook that hopefully behaves in the old way, and yeah, and we'll see whether we can write a second test that makes overriding it possible. Actually, I suspect we could write the second test while we're waiting. Right. Okay, the new test should do something like try sys.unraisablehook equal something custom own hook. F own hook will just collect the things. Hook args will just collect them into a list. Hook args, and then after the finally, we should set it back, sys.unraisablehook equal sys.unraisablehook. And now we should be able to say this kind of stuff, right? And at this place, the hook has already triggered, so we should be able to say assert len of L is 1, and then args, comma, equal L, and then assert args dot x type is type E, and assert args dot x value is E, and args dot test place in error message, right? I think that's a plausible test for the new behavior, I think. And then we can also say assert args dot object is none, or we can be better. We can say obj equal object, and then pass that, and then we should be able to retrieve it. Right. Okay, I think that's what we want to pass, but of course we need to fix my typos first. I'm not importing this thing, this object here. From pypy.module.sys.vm import app hook args, and I'm also calling it the wrong thing. Okay. New attempt. I actually have absolutely no idea where sys.acceptHook is called. There's a test for it at least. That's great. But who calls it? App main. App main is a really strange file. Can kill this tab, and let's look at it here. So this is basically a pure Python file. Right. Let's see. This is a pure Python file that runs after you start the interpreter, and it does stuff like argument handling and setting up all kinds of things, and it's just completely normal pure Python code. And one of its tasks is to be able to run, to call sys.acceptHook on when an exception should be displayed, right? Interesting. And it's not using the write unraisable thing, right? Instead, it's sort of emulating write unraisable in slightly wrong ways. I mean, this is okay. I'm going to context switch back to that, but first let's fix the new typo. So new missing one required positional argument dict. What? So I suspect that's very strange. Okay, I have no clue what's going on. Let me put a PDB here. So we get this internal message that's raised by something, but I really don't know by what. Maybe it's the struct constructor. Yes, I suspect it is. Where's the new? Maybe. Okay, let's rerun it and see where the error occurs. Bye, Batuan. Oh yeah, thanks, Matti. I was in a PDB. Sorry, I pressed Ctrl+C too quickly. Yeah, I could probably have figured out what the problem is. I thought it might be the constructing of the hook args. I thought it might be this call. Maybe not. Yes, I wasted lots of time there. Okay, struct seek. We were here. We were trying to read what the problem with the bug that Julian found is. And I think the problem with the bug of Julian is that this is a poor man's implementation, poor person's implementation of write unraisable, right? It wants to report something that is not unraisable, but it's doing it manually. And what we should do instead is we should instead call this new useful function that we wrote, right? This one. That we wrote it only for testing purposes, but it seems that here is some completely regular Python code that should really work by calling it. And let's actually grab for what, where does CPython call the except hook? No, let's context switch back. Okay, so where does the error occur? We can normalize the exception, all that's fine. We construct stuff, that all works. Now we get the hook class. That's my one suspicious place that could fail. Takes a while. Right, that fails. And what that means is that we did something wrong in our definition of this one. And I'm not quite sure why. Yes, because this should not be struct seek type everywhere, but struct seek field. Right. Yes. Okay. Let's wait some more. Another typo, basically. Okay, what I wanted to do while waiting is grab for except hook in CPython. There's just the definition. Maybe it's in Python run. There's thread except hook. Lots of things. Pure Python code. Yeah, so Python run is plausible. Right. Yes. And here now we understand the bug. So what CPython does is when it calls the except hook, it gets the except hook. It has the audit thing, which we don't support yet. And then what does it do with it? It calls the hook. So, and if the result is null, there's no exception, we're done. Else, why is it not using write unraisable here? I don't know. So it seems they do the same thing, just slightly differently. Right. Okay, I kind of expected there to be a call to write unraisable here. But it seems, yeah, they also do this slightly strange thing where they re-implement bits of write unraisable without using it. Maybe we should ask Victor why it's done that way. Or Batuhan has left, otherwise we could have asked him. Right. Yes, it looks very similar. Right. Okay, so we're doing something wrong. Or are we doing something wrong? Oh, yes. Nowhere. Our getUtter call is wrong in down here. GetUtter wants the attributes not to be strings, but also to be wrapped objects. So it should be new text around all of them. Slightly annoying. Missing parents, doesn't look like it. Okay. Yeah, I mean, I saw that by scrolling up and seeing that there's a call to getUtter in unraisablehook, and the name of the argument is wname, and that's where it came from. Matti is suggesting to change that to not take a wrapped string. I don't think that's correct, because there are lots of places that really need to pass it something that's already wrapped. But I suspect there could be another function that does that. Hi Ethan, great for you to join us. Yeah, if you just joined, we're a little bit in the middle of things. We're basically, I think we wrote kind of the right code, but it contains many typos, and I'm basically trying to fix them one by one. Right, so, and while we wait for the tests to run, we switch back to a bug that somebody found while I was streaming, and that is a difference in the behavior of sys.acceptHook. Right. Yes, so indeed, Julian was just typing that was just saying that this Python code looks pretty similar to this, except to this C code, so it's not quite clear what the difference is. Yes, typos are certainly really bad, but what makes it much worse here is that the turnaround time is pretty slow, because we're running all of these, we're running all of the tests I mean, all the test runs are really slow. It's not like in the log stream where it was a really small interpreter, so tests were quite efficient. Here we're running this really big Python 3.8 interpreter, and we're running code on top of the interpreted interpreter, so that always takes uncomfortably long. And then, I mean, yeah, another one. If you have a turnaround time of a minute per typo, it's a little bit annoying. Here, we're missing an import. Interpreter.error import. Right. Another time. I could remove the PDB, I think. I'll put it here. Okay, let's wait. I'm not to talk more about the C code here. I'm not completely convinced that syslog module. Where's the sys module? The C Python sys module is in Python sys module, obviously. No, Julian is right. So it seems the difference is really in the, for the bug that we are concurrently trying to analyze, the problem is really in the default except hook of PyPy. Yeah, so PyPy's default except hook, where is that? Except hook. PyPy's default except hook is a little bit more complicated than CPython's, and that's what's leading to the issue that Julian found while playing around with things. But yeah, my real question is really, if you mess up your except hook, why doesn't it trigger a write unraisable? Why does it instead, yeah, re-implement write unraisable in a worse way? So we should, I mean, I think we should file a bug to CPython asking why this code here doesn't call write unraisable. Okay. Okay. Another typo. But we're getting closer. Another typo here. We didn't pass the space argument. Actually, I'm wondering, maybe it would be better not to have any optional arguments here. So Ethan is asking, that's a fantastic question, thanks Ethan. Why is R Python compilation not incremental? And it's a great question because I can talk about something while we run for the next wait for the next typo. Yes, I think, I mean, I did this 15-year PyPy retrospective a couple of years ago, and I really still think that not thinking about R Python incremental compilation was really the main strategic mistake we made very early in the project. And yeah, we didn't design it in, and sort of doing it retroactively is quite hard. And so yeah, I mean, basically the more code exists, the more annoying it gets, and nobody ever went back and did it. That's not completely true. There was a master's thesis that tried to think about how to make RPython incrementally compilable and have proper modules and stuff like that. And but nobody it wasn't merged. It wasn't completely thought out, and it wasn't merged. Yay, we're missing another one. Why? Type value traceback. Error message object extra line. Error message object extra line, right. Matti, didn't you recently look for the incremental compilation thesis thing? I think there is even a branch, but I suspect that it's probably bit-rotted, and yeah, I mean, I think the answer is that it would definitely be possible. It's just a very annoying project, and despite us suffering from the non-incrementality daily, nobody spent the, I don't know, 2 months or 3 months of work or whatever it would be to go and fix it, which is really a sad state of affairs somehow. But yes, it would be really cool to have it. I think the answer, and there's no real technical reason why it should be unfeasible. And yes, it's really bad for us that it's not there. Yeah, it's from 2010 or something maybe. Right. Getting there. Julian, do you feel like finding a CPython bug, or should I ping Victor on Twitter or something to figure out why it's done that way? Hi Tobias, great to see you again. We're running both tests immediately. Cool, thank you, Julian, for volunteering to find the bug. They might well close it as there would be a difference in behavior. We cannot do it, but I think it. I mean, to me, it sounds like a reasonable request. Right. While we wait for this, we should write our next test. Here. I think that the main next test I still want to write is a test that makes sure that we use the default reporting, like we fall back to the default unraisable hook if if our new unraisable hook has a bug. Right. So we have our own hook, but the own hook is evil or broken, and it raises, and it should raise a different error. Actually, I don't really know how it behaves. Let's try. Let's try and see Python. Both our tests passed. That's really good. We managed to get rid of all the typos in the implementation. So the tests passed. So that's great. So then basically, I think we're getting pretty close to be in a fairly good state. But I mean, the test that I still want to write now is I want to see what happens if we write an unraisable hook, in what happens in CPython if we write an unraisable hook that raises an index error because it's broken. Right, and then okay, we need to go the slow route of creating or can we use the, we can, okay. It's not actually less annoying, so let's go the old route. We make a class with a del, and that del raises, and we make an instance of that and another one, right? And so now we get exception ignored in sys.unraisablehook function hook, and we get a type error. Aha. Okay, you get a type error because that's not what I wanted at all. I wanted to really I mean, that's also interesting to see, but right. So right, the exception we get reported is the last one, this one here. We don't get, I mean, this value error is really swallowed then, which I think is reasonable. I mean, if your unraisable hook is broken, then okay, then you just report that error. I'm not really sure we implement that yet. I mean, it works that way yet. So let's see. We have a hook, it raises. Let's turn this into a test. So, and then we call write unraisable, and now we need to inspect sys.standard error, right? We need to say what we did up here. We should really write some machinery for this, but just going to do it once. Right, like this. Now we should inspect standard error and say this. And we want to see the index error. And we want to say something like assert own hook in output. I'm not really sure that works. I think we don't switch to the new exception yet. So I need to. We might have to do some more work. I suspect that the first two tests pass, but the third one doesn't. Yeah. So the first test is the default behavior. The second test is we can change unraisable hook and it does something sensible. And the third test is we override unraisable hook, but it's broken, and then we still want to get the bug in the unraisable hook reported. Right. So somebody please ask questions so that I can talk about something for the next 3 minutes. Otherwise, I'll actually go back to here and try to look at the C code some more. Right. Yeah, I see how it happens now. So what they do is they try to call the hook. And if the hook fails, we're done. Great. If the hook doesn't fail, if the hook does fail, then the object that we want to report as faulty is the hook. And we're not using we're using this here as the error message. And then we're fetching the new error, the one error that was produced by the hook. Right. So we can certainly do that. Test is still running. I suspect that the third test will fail because it will report the wrong exception. So where's the code? We're calling the hook here, right? And then if the hook produces an exception, we want to switch out stuff. We want to say, okay, the object is now the hook, and we're reading again the value, the type, and the traceback. But this time we have another instance of operation error. Remember that we are already in a method on some other operation error, but now we're getting a second operation error, and we want to use the fields of that operation error, like this. Right, and then we pass those into the default implementation. Right. Yeah, that looks like better code, and now we'll see it fail, and then we need to rerun. So there's a question. By Luke. Yeah, that would, yes, that would very much. Luke is trying to work on the JIT, but that's context switching a bit too much. I can't think about something that's completely outside of the current topic. Sorry. Yeah, ask something about the interpreter. That's sorry, I was right. Indeed, this makes sense. So we get exception ignored in sys.unraisablehook, but the object is still the wrong object. That should be switched, and then the value error is wrong. So the test is not written correctly, but it would have failed anyway. So we should fix the test and then rerun it. So we don't expect the original error message to still appear. We want there to be this string in the output. Is there a... Right. And then we want to see the name of the hook, which is onHook, and we want to see that we get the index error. Okay, let's rerun. Julian is saying that he filed the bug. That's great. And he can't add me to nosy. How do I add myself to nosy? Right, good. Do I need to say submit changes, or is that it? Yeah, sorry. I'm not entirely sure whether I'm now in the nosy list or not. Do I need to press? Right. Okay. Thank you. Waiting. Okay, I hope it's So Ethan says that he always read it as noisy and not nosy, but bugs.python.org is definitely also very noisy somewhere if you're on the noisy list. So right. No, actually, I knew it was nosy because long ago, PyPy also used the same bug tracker. What's the software called again? I forgot. Right. Roundup. Yes, thank you. Yeah, when PyPy started, there wasn't really any usable hosting like GitHub nowadays, and we had completely our own infrastructure, and including our own Roundup instance. There was SourceForge, but that was using CVS, and we really didn't want to use CVS. And so we had our own server called CodeSpeak that had Subversion hosting and Roundup and mailing lists and stuff like that. But then after Bitbucket started to be a usable Mercurial hoster, we switched to that. Right, we can actually look at the diff while we wait. Right. Lots of changes. Move some code around. Actually, there was one comment that I still wanted to look at. Okay, there's still some extra white space here. Wait, where was that? Interp magic. A new write_unraisable function, right? That we use for testing, but we would also use it for a broken sys.except hook, and then unraisable hook is exposed twice, once as the one that we call, and once as sort of the way to get back at the original unraisable hook. and then there's a new class, a new struct seek type that for the unraisable hook args with all kinds of arguments. One thing I still want to do is grep for the extra line where that is actually ever passed. Right, and then there's the default unraisable hook, which basically unpacks the unraisable hook args again and calls the default implementation. Right. Okay, so what's the test doing? It's passing. Great. Right, exception ignored in test unraisable hook. Blah blah blah. There should be a space there somehow. Here. We get a traceback. That's great, and we see the we see both exceptions. That's even better. So we see it's nicely chained. During handling of the above exception, another exception occurred. Cool. That's good. So that's certainly great. So let's look at the write unraisable with some context too, and let's see who passes the extra line stuff. Right, that's the one we just added. That doesn't count. Socket doesn't pass anything special. That's a callback from C code, where we certainly can't pass an exception through C. Just random C code. Another callback. There's an extra line here. We could look at this. I mean, just out of curiosity, I kind of want to understand what the extra line is. CFFI, C callback. Right. Oops. Right, okay. It's telling us what kind of thing is going wrong. It's doing the call. It's all callback stuff, right? It's calling back from C to Python, and it's preparing the arguments, then it's doing the call, and then sometimes converting the result back to a C type fails, and then we get this extra error message. Great. Very user-friendly. And are there more? That was one. Another callback one. That's the default implementation. Various hooks. They don't have it though. That's all fine. That's the implementation, and we're done. Right, so the only thing that uses the extra line special PyPy specific argument is the CFFI code that uses it to be extra nice about where exactly the error occurs. Right. Is there another call of this or not really? Who calls print error? It's called twice. During the call to on error, another exception occurred. Okay, fair enough. So there's various other error hooks here as well that I don't really know anything about. Okay, I think this is pretty good. Right. Yep, I think that's it. I'm going to look at the diff some more again to spot obvious problems. Let's commit it. Can I not? I thought I can go back to the issue again somehow, but seems not. Ah, it's still here. Sorry. Right. Yes. So I think that's kind of it for me tonight. I think we did a slightly complicated deep dive into some of the internals of how exceptions that appear from places that that you don't really want an exception to be in how that works. And now we added this somewhat indirect mechanism to allow the user to report them in different ways by shoving them to some logger, or to have some error reporting web service or whatever. And it seems like a useful thing to have in a production setting where you don't just want to lose these strange unraisable errors. Right, and we learned a little bit about how exceptions work in PyPy, which is that they're wrapped in this special kind of RPython exception called an operation error. And and that we also saw that in PyPy, exceptions on the application level, on the Python level, are really mapped to exceptions on the RPython level, which is certainly much nicer than having to check all the results of your C calls and see whether they raised, and then keep raising, and that kind of manual exception handling that CPython does. Of course, exceptions in RPython are actually compiled into exactly the same kind of C code, but we don't have to do that ourselves, so it's nicer to use. Okay, thanks everybody for joining me. I think that's it for me for tonight. This was fun, certainly more fun than last week. I need to admit that I still didn't actually finish the reverse stick thing because it was so painful that I need to wait for another couple of days before I find the courage to do the remaining 10%. Thanks everybody for joining me. Oh yeah, Matti is right. We also saw struct seek, which is a fun little file. Thanks everyone, and have a good rest of the weekend. Bye.